with Micronaut and GraalVM native image. With microservices, I think one is the architectural benefit of breaking down code into smaller units, but then there is also the performance aspect to consider, and this is where we will learn how the combination of GraalVM native image and Micronaut can lead to efficient, highly performant, and optimized applications that can be deployed easily to environments like Kubernetes or serverless platforms on AWS or Azure or any of these cloud platforms. So this is a great topic, and we have a great speaker to unpack it for us. Alvaro is a passionate software architect and agile enthusiast with over 20 years of experience. He started his career in 2001, coding first in Perl and Java, but then he quickly shifted to Java EE, working for companies like IBM DCS, BES Systems, and Sun Microsystems. He is right now a principal member of the technical staff at Oracle Labs, where he is a Micronaut committer who helps to maintain and evolve the open source framework. Alvaro is a widely respected speaker at conferences like GCon, JavaLand, JavaZone, and CodeMotion. Alvaro, thanks for taking the time out to join us and do this webinar. Really privileged to have you join us today. Over to you.
Yeah, thank you. Thanks for the presentation, and thank you everybody for joining this presentation. I will share my screen, and then we can begin this presentation. So, yes. Actually, hold on a second, because I think you're seeing. I will share again. Yeah, can you see the presentation
Yes.
full screen?
Yes.
Okay. Great. So, so let's first of all introduce myself. So my name is Alvaro Sanchez. I'm coming from Madrid, Spain. Like it was said in the introduction, I've been working with Java since 2001. As of today, I'm working at Oracle Labs, mainly on Micronaut. Those are the areas where I'm mostly focused, which are the Maven plugin, object storage integration, Kubernetes module, Micronaut cache. But I contribute everywhere where I can. And I have been working on Micronaut open source since the beginning, since it was created 4 years ago. No, sorry, almost 6 years ago. So yeah, and I'm not a developer advocate or DevRel, just a software engineer working on the project. But when I have the opportunity to do a presentation about Micronaut, I enjoy doing so. So that's the reason why I'm here. Slides are available on speaker deck. So this is the link. I'll share the link as well with the organizers, so they can publish the link afterwards. So we're gonna see an introduction about Micronaut and then GraalVM, and then if we have time, a little demo about how things work with live coding. So what is Micronaut? So there's 3 ideas I would like the audience to get from this presentation or from Micronaut. One is that Micronaut is a modern Java framework. It is modern because it has been designed from scratch in 2017. So unlike other traditional Java frameworks like, for example, Spring or Jakarta EE, that were designed, I don't know, 15, 20 years ago. We could think a few years ago about the type of applications that were created in that moment, right? So we could forget about, I don't know, for example, application servers and Word deployments and things like that, and focus on modern architectures like microservices, serverless, cloud deployments, etc. The second idea is that Micronaut is a general purpose framework. So you can use it for all kind of applications. So typically people use it for creating REST APIs. But you could use it for creating I don't know, a command line application or a message driven application where there is no server at all, like a Kafka consumer or producer or both. A serverless function that you deploy on AWS Lambda, Cloud Run, etc. So general purpose framework. And the third idea is that it is highly optimized. We essentially leverage a Java facility called Java Annotation Processing API, APT, Annotation Processing Tool, that let us hook into the compiler and essentially generate or compute the framework infrastructure at compile time instead of doing that at runtime. And the result of this is less memory consumed and much shorter startup time. The way we do that is with something which is called AOT, ahead of time compilation. So at build time with this compiler hook, we essentially produce all the framework infrastructure. Like for example, when there is a dependency injection to be done, or when, I don't know, you're using Micronaut data, there is a transaction that has to be started and stopped or commit, AUP proxies, all the bin introspections. So everything is created at build time. So we analyze at compile time the source code and produce bytecode. So the result is that at runtime, there's no reflection, there's no proxy generation, there's no dynamic class loading. We don't scan your application class path. So everything is much faster. Like I said, it's a general purpose framework. So you essentially can use it with any language, build tool, test framework, React library, cloud, etc. Well, not any language. So Java, Kotlin, and Groovy are supported. But regarding the other technologies, the most important ones are already supported. We started this in 2017, like I said, and then 2018 was 1.0. We're currently at version 3.9, and we're about to release Micronaut 4. Which is the next major version. I will mention some new features of version 4 later in this presentation. But before that, I will do like an overview of the features of the framework. So the core of the framework is a dependency injection runtime. Where you can use JSR 3.0 annotations or even Spring annotations. Regarding the Spring support, by the way, we support the majority of the Spring annotations in such a way that at compile time we translate those annotations into Micronaut ones. So it is possible to grab an existing Spring applications. Sorry, existing Spring application, then add the Micronaut annotation processor to the class path and the runtime dependency as well, and run the application as a Micronaut application, as a Micronaut frontend application, but with Spring source code. provided that the annotations that your application is using are supported. There is an extensible configuration mechanism where you can have different type of application files and environment configuration. So everything you're used to is supported. There is validation support. So by default, there is a module called Micronaut validation, which is reflection-free, is faster and smaller, and consumes less memory than Hibernate validation. But if for whatever reason you prefer to use Hibernate validation, you can use it. There is an AOP framework, but again, instead of doing that at runtime like other frameworks do, all the AOP infrastructure is generated at compile time, and is also reflection-free. This will be like a hello world REST controller with let's say method that is accepting GET requests and is producing text plain response. So really simple. But there is also an HTTP client. So there is this is an example of an AOP annotation, which is built into the framework. This allows you to create a declarative HTTP client where the implementation will be generated at compile time. So you have an interface with a net client annotation, and then the actual implementation of the HTTP client request and response and JSON processing, if anything, will be generated at compile time. So this is similar to Spring Cloud OpenThing. The difference again here is that everything is implemented at compile time. In terms of message-driven applications, there is support for the major technologies. Same for data. There is a module called Micronaut Data, which uses the well-known repository pattern. So again, this is similar to Spring Data. But again, the difference is that everything is generated at compile time. There is also some nice things like, for example, depending on the method name, the query will be generated. So there is a base repository interface that provides the basic operations like find one, find all, persist, etc. And then, like I said, based on the method name, the query will be generated. So if it's find, it's a query, and then we inspect the return type to determine that is a collection, and then there are like operators to order by or filter, etc. So, and the good thing is that everything is checked at compile time as well. So assuming there is a user domain class with name attribute, if you were to have a typo here in this parameter name, it will not compile. Your application will not compile. But not even in the attribute in the parameter name, but also in this string. So for example, if this enable property you were to introduce a typo here, your application will not compile. As opposed to, for example, in other frameworks, you get a runtime exception when the query is to be executed. But we check that at compile time. In terms of security, more or less everything is already implemented. So JWT, OAuth 2.0, OpenID Connect, etc. So we essentially got you covered. And there are many more things. distributed tracing, service discovery, distributed configuration, monitoring. I don't know, a lot of support for container-based development, either directly with test containers or a new extension called test resources that manage the lifecycle of containers during the execution or the tests of your application. There's cache support with different implementations, annotation-based as well, email or handling, etc. So this is more or less an overview of all the features. You can get started with Micronaut by going to launch.micronaut.io and then generating an application. You select the version, language, build tool, test framework, and then the Java version you want, and then select the features that you want to include. Like, for example, you would say, I want an application that has Micronaut data JDBC and has open APIs and has Micronaut security and has GraalVM support. And then we produce Maven or Gradle build, depending on the selection. We generate a build with all the dependencies set up, the configuration properties that need to be used, etc. So like a skeleton application. You can download that into your computer, or you can even push it to GitHub from here. If you prefer working on the terminal, there is a command line application like a CLI that you can install and do the same thing. In case you're using IntelliJ IDEA Ultimate, there is a support for Micronaut. But essentially, all the things that you're seeing, both Micronaut Launch, this wizard, they are all using the same backend. So it's like a different front end for the same backend. And finally, there is also Visual Studio Code support with the GraalVM extension pack, in case you're a Visual Studio Code user. In terms of Micronaut 4 features that we are going to be introducing, one of the most notable changes is that the baseline has been increased to Java 17. So Micronaut 3 currently supports from Java 8 and forward. However, with Micronaut 4, we're increasing the minimum version to 17. This essentially enables us to use internally through the code base, all the things that have been introduced in Java between versions 8 and 17. So the Micronaut code base itself is going to be better. But also allows us to offer support for some features that have been introduced after Java 8, like, for example, virtual threads, the new HTTP client, etc. So starting from Micronaut 4, the minimum version will be Java 17. However, if you are using an older Java version, you can always use Micronaut 3, which will be supported for many years. The Micronaut 4 will also support the latest versions of other languages like Kotlin and Groovy. There will be a new Micronaut data release that will support Hibernate 6 and Hibernate Reactive. Generally speaking, the Micronaut runtime is smaller, is lighter, and is faster. We're getting performance closer to raw netty. In Micronaut 3, Hello World application would start up in I don't know, 350 milliseconds or 400 milliseconds, something like that. So we're speaking about half of that with Micronaut 4. So it's a great improvement with span of some modules from core, which are now optional, in some dependencies like Jackson or SnakeYAML that not everybody needs them. So, for example, instead of Jackson, you can use Micronaut serialization, which is an alternative um, that actually supports all the Jackson annotations or the majority of them, but is much faster. It doesn't use any reflection at all, so it also consumes less memory. And yeah, there are a few other things here and there updated for Micronaut 4. So if anyone listening to this webinar is already using Micronaut, I recommend to check it out. There is a milestone published already, and we're aiming to publish like the final release this quarter. One of the other things that are going to be introduced is a compile time expression language, similar to Spell, this pre-expression language. But again, the difference is that it is compile time checked. It could be used for things like, for example, in this case, the expression is referencing a variable which is actually a parameter of the method. And we compile time check that you didn't use a typo there, because at the end of the day, at the end of the day, this is a string, but the Micronaut compiler will check that. Or you could use the expression language for doing like a conditional routing. So this is like a REST controller with get mapping, but in this case, the mapping is conditional to this condition based on the request. And another thing that will have Micronaut 4 is something called control panel. Micronaut control panel is development mode UI for your application that will allow people to better understand what is happening inside their applications. Basically, the application health checks, a view over all the environment properties, all the HTTP routes that have been resolved, all the bin definitions that have been loaded, and even interacting with the loggers interface. So, like I said at the beginning, in terms of configuration, Micronaut have the notion of property sources. So essentially, the configuration of an application can come from different sources. So you will be able to see them, to see all the properties that they contain. Each property source has an order. So at the end of the day, a property source with bigger precedence will, will potentially override configuration properties from other sources. So you can essentially tell well, where are those configuration properties coming from. You can also see, like I said, all the bin definitions and the dependencies between them. And finally, interact with the logging system by changing on the fly. You can change logger level or add new loggers, remove loggers, etc. So this is useful if you want to debug login to something in particular while the application is running. But like I said, this is all intended for development mode. The next section is an introduction about GraalVM. So GraalVM is a OpenJDK distribution, like that, like any other JDK, OpenJDK distribution. So you can use it as your local JDK installation. That's what I do locally. I locally use GraalVM. Um, and like is a drop-in replacement for any other open JDK distribution that you may use, like Eclipse Temurin, um, um, or any other, I don't know, Amazon Corretto or Microsoft Build of OpenJDK. So you can use it like that, or you can use it to produce a head-of-time compilation for Java. So essentially with GraalVM, there are two options you have. One is using Java-C and Java to execute your application as any other OpenJDK application. And the other alternative is to use something called native image that will produce a native binary of your application. And actually, this native image component has been donated by Oracle to OpenJDK. So future OpenJDK versions will have this native image component as well. GraalVM is supported in all the popular Java frameworks, so Spring, Quarkus, Helidon, they all support GraalVM as well as Micronaut. However, the combination of Micronaut and GraalVM is special because you'll get really low startup times, really small memory consumption, and depending on the GraalVM version you use, like for example, if you use GraalVM Enterprise, you can get even better throughput with less latency thanks to the profile-guided optimizations that GraalVM Enterprise has. So like I said, the Micronaut and GraalVM is the best integration possible for GraalVM into a Java framework because of these three reasons. One is because both technologies are being created and supported and maintained at Oracle Labs. And the second reason is that Micronaut is ready for GraalVM native image since day one. Unlike other frameworks that took some time to support it, we are ready since day one because of the design of the framework that I mentioned at the beginning. So there's no reflection, there's no runtime proxies, and that is essentially working better in GraalVM. It doesn't mean that you can't use reflection with GraalVM. You actually can. You can use reflection, runtime proxies. So more or less everything is supported, but there are some times where you need to tell GraalVM. For example, if you're going to initialize a class at runtime, you need to tell GraalVM in advance with what is called the GraalVM metadata. Because basically GraalVM needs to pack that class into the native image when building the application. And because that doesn't happen in Micronaut, has been generally easier to integrate GraalVM into Micronaut applications since the beginning. And the last reason is the GraalVM extension pack. It is maintained by Oracle Labs, and it has support for both GraalVM and Micronaut applications in Visual Studio Code. There is one use case that I would like to highlight, and is Disney Plus. Disney Plus, as it was published by AWS, Disney Plus is using Micronaut and GraalVM in Amazon Lambda. And in that post, they explain the reasons why they choose Micronaut and GraalVM. But as you can imagine, it has to do with the cold startup. So one of the things that they realized was that the cold startup time of a function would decrease if you would increase the memory allocation of the lambda. So lambda with a bigger memory allocation would take less to start up, which makes sense because there are some initializations that happen during cold startup. So essentially, if the lambda is more powerful, has more resources, will take less to actually start it up. And then the second conclusion is the comparison with regular Java runtime versus GraalVM native image. So you can see the call setup is a fraction of that. It's actually something like 10% or even less. Is really fast. So for example, this case of lambda lambda with 3 gigabytes of memory assigned. It will have a call startup time of 83 milliseconds versus 3.6 seconds if not using GraalVM native image. Okay, so it's time for the demo. Actually, I'm going to share a different screen. In front of me. Okay. So this is an empty Micronaut application. It's not really empty because it has flywheel migrations, right? So so essentially there are like a couple of flywheel migrations that will create a table and insert some data into it to save some time. But other than that, this is an empty Micronaut application, Maven based. So it has the typical entry point, like the main application class, and then resources directory with application YAML and loopback. So I have the flyway and micro data configuration already defined here to create or to use an H2 in-memory database. So let's create some code. So first of all, I'm going to create the entity, which is going to be a record. I have GitHub Copilot installed, and this is smart enough to autocomplete my own demo code, which is great for this presentation. So I don't have to do it. So we're going to annotate this with at entity, and we have to add a couple of annotations here. So the and then it's generated value. I'm using Jakarta persistence API annotations, as you can see. Hold on a second because I'm gonna take my notes. I'm back. So this is a regular JPA entity, nothing new. The next thing I'm gonna create is I'll create the repository. So this is an interface that is going to be called team repository. And this guy here will stand CRUD repository. CRUD repository is a Micronaut database interface for CRUD operations. So this has like save, update all, etc. And I'm going to be annotating this with a JDBC repository. And I have to specify the dialect, which is S2. And that's it. So for this demo, I'm fine with the CRUD operations. I don't need any custom query. So this is it. So one thing to mention is that I'm using JPA annotations, but this application will not use JPA, will use JDBC. There are two flavors of Micronaut data. One is Micronaut data JDBC, and the other one is Micronaut data JPA, which is Hibernate under the covers. So for this version, we're using the plain JDBC version. So internally, this is using JDBC under the covers, so there's no JPA. But at source level, we can use JPA annotations if we want. So this is one of the great things. What else? So let's now create an abstraction, and you will understand later why. What is that? So I'm gonna create an interface which is going to be called Team API, and I'm gonna use this interface as contract for both the server and the client. The server is going to be implemented in a controller, and the client will be used on a test. So those are the methods that I'm interested into, and then I need the annotations to make the methods executable. So this API is going to have a couple of endpoints. /teams will list all the items, and then /team/ID will retrieve that particular team. Really simple. So now let's create the server. So this is going to be a controller, team controller. So let's implement the interface. We are going to add the annotation controller, and then for the path, we're using this constant that we defined on the interface. This controller will make use of the repository that we created. So let's create a constructor dependency. Like that. So Micronaut will dependency inject team repository instance into this constructor so that we can use it. And then implementations are really simple. So this is repository final. We can return entities or collection of entities directly in the response type of a controller, and in that case, depending on the result, Micronaut will produce one response or another. So essentially, if there is something in here, then it will be a 200 response with the JSON representation of the team of this particular entity. If we return null, then internally it will be mapped to a 404. We could return an optional if we wanted to, or we can even wrap the response types with reactive operators. Like, for example, we could use reactors flow or mono. In this case, it would be, we could return like a flow of theme, and then Micronaut will subscribe to that flow and will emit the results to the client. And in the cases where we want to customize the response, like, for example, if we want to add custom headers, or we want to customize any of the elements of the HTTP response, we can wrap the return type into an HTTP response object. So in this case, I'm doing that for returning the the result. So I'm using the find by ID method of the repository, and this guy is returning an optional. So if present, then I will map it to an OK response with the particular theme as the body. Otherwise, I will return a not found. As simple as that. So we should be able to run this application. There are several ways to run this. One is like this is like a normal class with a main method. You could do this from any IDE. So there's no IDE required, no build tooling required to run a Micronaut application, because it's like main like a class with main method. So you can simply run this. And it runs. Let's create a terminal. Actually, I will use a terminal here. And then we can curl like that. And we have a response. We can curl one thing by ID. And if we put a non-assistant ID, we get a 404, right? So this works. We can also run the application. Let me stop this for a moment. Where are you? So Windows run. There's nothing running here. Oh, this is not the window. This is it. Okay, makes sense. The other option, the presentation mode. The other option is using the build tooling. So I can do MVM. Make sure I don't have anything running. So I can do MVM mn run, and this will run the application in development mode, meaning that we will scan your application for changes, and if anything changed, then we will restart the application. And then one thing that I can also do is to produce a native image. So if I say Maven package without any extra arguments, that will produce like a regular jar file. But if I specify packaging to be native image packaging, then that will produce native image of my application. On modern hardware with latest versions, this takes about a minute, a bit less than that. When I first started doing this presentation some years ago with the original versions of Micronaut and GraalVM, also with an older laptop, I couldn't finish the generation of the native image during the presentation because it was taking like much more time, like several minutes. But every new version is faster. Also, hardware is faster, so I'm using an M1 MacBook Pro, which also helps. But you can see that now in less than a minute we'll have a native image, and then you will be able to see how long it takes to start up. So I will make this a bit bigger. It took like 1 minute 8 seconds, including all the Maven execution. So the actual native image generation took me a bit less than that. And running it takes. Let me run it again, because if you blink it, you miss it. 38 milliseconds. And this is not well, it's a hello world, but it's not like an empty or blank application, because it has Flyway. It's actually running Flyway migrations as part of the startup, creating the schema and inserting some data. And everything took 38 milliseconds. So as you can see, this is really, really fast. And the last thing I want to show is the testing experience, which I think is great. So we've created a hello world application. Now let's create a test. So let's call this team controller test. And this is Micronaut test. The Micronaut test annotation will take care of running your application in a random port, and then allowing you to inject any beans that you want into the test class, so you can actually make assertions on your application. This is really great because we are talking about a real functional test. So this is not a unit test. I'm not mocking anything. I'm not mocking the interfaces. I'm not providing dummy implementations of those interfaces, but it says I will be running the whole application as part of my test, but that will be done really, really, really fast. So like I said, I created a REST API. So one thing I could do is to grab like a low-level HTTP client, and then make a request to the server, and then make an assertion of the response. But it would be great if we could use a declarative HTTP client. And now is where this team API interface that I created at the beginning will make more sense. So I will create like an inner interface called team client, which stems team API, and this is at client on path, which is this constant that I created. So with this inline definition of a client, since this interface contains the contract, like I said, I have a strong contract through a Java interface that both the server and the client are implementing the same API. So that's the inner interface definition, and then I can simply inject that client here. So I inject the thing client, and then let's create the test method, which is like this with the imports, and this is a net test. So if I run this test, it's great because I'll do it again. Running this functional test took 384 milliseconds, and again, including the REST API initialization, Flyway initialization, everything. And to make it clear that this is like a functional test with no mocking at all, I have in my logback configuration the trace level for the HTTP client, so that we can actually see that the HTTP client is sending a GET request to the /teams endpoint in a random port. It's so magic that we even didn't have to specify on which port the application is running. So Micronaut will figure out. And then this is the GET request. This is the response received with the JSON, and then I can use this team entity class and make assertions on that, so I don't have to parse any JSON. I don't have to use any low-level HTTP client to do any of that, and everything took, like I said, 1/3 of a second. So it's incredibly fast. This testing experience is one of the most notable differences of Micronaut versus other frameworks, and will make you reconsider your testing pyramid. So we're used to, or basically traditional Java frameworks introduce the best practice of creating lots of unit tests and then fewer integration tests and then very few functional tests. So that's the typical testing pyramid. And that is only because functional testing and integration testing in those frameworks is really expensive. It takes a lot. But when it takes so little to write the test and to run it, you will actually think twice before mocking, because for this thing, I could have written an integration test for the repository. I could have written I don't know, a unit test for the repository as well, mocking other things. I could have written a unit test for this controller, mocking the repository. So there's several things that I could have done, but I think it's much easier to test the whole thing together. So this is all that I have to share today. I don't know if we have any questions.
Hey, thanks a lot first, Alvaro, for a great presentation. I mean, we did have a session, I think a couple of years back on Micronaut and GraalVM, and back then the code starts were a little slower, and then we could see that they're like in this much bigger performance boost now with respect to that. So some of the questions that keep, I have some questions that people on YouTube and all on the Facebook stream compiled some of them for you. So one question is, what is the appropriate use case to use GraalVM and Micronaut as opposed to doing plain Spring Boot microservices?
Right. So one evident use case is serverless, because in a serverless environment, if your function have a smaller call startup, you're literally saving money, because in the cloud, especially Lambda, you're billed by the duration of your function. So again, what happens normally in a serverless environment is that the initial invocation after a period of time of a function is what is called the call startup. So the function has to be initialized, and then it is kept warm for a while if the Lambda keeps getting requests, right? So warm startup is not a problem in the framework. I think the difference is the cold startup, and this actually allows you to move to serverless for more scenarios that you previously considered. Because perhaps there was like a small piece of functionality of your application or your system that previously would take a lot to initialize, and you would never consider serverless an option. But with GraalVM you can, because the startup time is so small that you can turn that functionality into serverless function, and then be only billed by the actual duration of your function. Serverless is one clear use case. Another use case is a Kubernetes. So if you deploy your application into a Kubernetes cluster and you do rolling deployments with different replicas, um, if if you have a pod with your application that starts up in, I don't know, half of a second, it is much better than if the pod takes 5 seconds to start. So you will generally need to have like less replicas for your application to do these rolling deployments, because the replacement of the pods will happen much more quickly. Those are
Right.
the use cases that I will highlight.
Right, great, great. And then the other question is slightly more technical. So when we're using these native images, one of the concerns is that they're good for like a smaller heap, but if it's a large heap, are there latency issues that we have to worry about?
I don't think GraalVM is restricted to small heap applications, so there's any of that. So GraalVM has its own optimizations. There are two editions. One is the community edition, which is what I was using. Then there is also like a commercial edition called GraalVM Enterprise, which is included. It's included for free if you are using the Java subscription or are deploying on Oracle Cloud. So that's already included. So if you have one of those, then you can start using GraalVM Enterprise for free. And but in any case, essentially, even the community edition has optimization. It has its own garbage collector algorithm. So I don't think it is constrained to small heap applications. So I really recommend people checking it out, and especially if there is a concern about the performance, I really recommend checking out GraalVM Enterprise. Because it has something called profile guided optimizations, PGO. And with PGO, GraalVM Enterprise is able to be, they have some examples that are compute intensive applications that perform better in GraalVM than in their native counterparts, like in C++ or C or whatever. So it is really performant. I really recommend people to check it out.
Got it. Yeah. So thanks a lot. I think that's all the time we have for questions. At top of the hour, we're at 7 p.m. So we'll close the webinar. But before I do that, I would like to thank you, Alvaro, for a brilliant session. Divided roughly half and half between slides and the walkthrough. Both of them are like especially illuminating. Thanks a lot for taking the time out, and we hope to bring you back for another session sometime soon.
Yeah, my pleasure. Thank you for organizing this, and I hope people enjoyed this presentation. I encourage everyone to check Micronaut or to keep using it if they're already using it, and hopefully we can see each other in a future event. So thanks everyone.
Thank you. Thanks a lot.
Cheers.
Bye-bye.